Good evening. Welcome, Steve. Yeah, another session of V0 fixing today. I actually was using the printer a lot this week, and it's printing really well. Actually don't have any parts to show, which is a shame. But it's printing really well, and I also, hi the Ravenkeeper, also figured out mostly the issues with the PC probe. Um, I will talk about that in a second, just like in case somebody follows along. Um, But yeah, so today, what will we do? Let me just get this entire stash of stuff over here. Most of what we're gonna do today is panel clips. So I was quite annoyed about the clips for some time, because every time we work on this machine, you have to unscrew all the panels, and it takes quite a long time. You have to put it back. It's just a bit of a pain. So I was looking for new panel clips, and this is what I found. I actually have the link in the description in case somebody is interested in doing the same. So this is from Wonderbra, I guess, which are the Voron Zero magnetic panel clips. I actually want to design something like this myself because I kind of had the idea to just like, like magnetically take the panels on and off, or take the panels off, put them back. But I found this, and it's kind of like exactly what I wanted to do. So let's just give this a shot. Maybe we do some iterations on that. It's quite a lot of parts, like you can see. It's obviously like a lot of panels. Oh yeah, like these parts are printed by V0, of course. So we can take a look at them in a second. And so that basically includes the door and like the four panels basically around it. We will leave the head as is. So I'm curious how this will look, because like the panels, the clips here will be like a bit thicker, because the magnet part on the back. Um, so they always consist of two parts. We need to see how it goes together. So there's the part that is on the extrusion basically. There's the part that is on an extrusion, and then the part that has like a indent here, that is on the panel, and then they basically clip together. But that means we will add like around 3 millimeter in thickness. So these clips will be like further back than the ones on the bottom. Let's see how it turns out. Potentially we will like do a slight iteration on these, just like to raise them and make them the same. I don't think we need magnetic panels on the hat. And I think they're actually structural, if I remember correctly. I'm not quite sure how the hat is put together. Oh no, they should still be blind joints. Nevertheless, like, no need for them to be magnetic, but maybe we do some iterations and improvements there. Get that started here. Yeah, so this is the one project. There are also these two parts, which are the bed sheet alignment helpers. I forgot the nickname. Somebody last stream basically said like they designed these. They sent them to me, and here they are. So we'll also put those on. I also have the printables link in the description. Basically, what they do is like we will put them to the like on the end of the bed, and they just guide the bed sheet into position. So you don't have to like fiddle around with like aligning it. You can just like fire it in, and it will be in place. So that's actually quite cool. And this is the random honeycomb storage wall piece that's kind of like made its way in the stash. Um, yeah, so these are all the parts we need. Um, then we obviously need a lot of magnets. So I just ordered 50 of the magnets. I think we need like 20-ish, 20, 24. So we have magnets. And then because we have this like 3 millimeter gap, I had a quick click. My thinking was, let's just add foam to close the gap. So that wasn't mentioned in the printables, so I'm not quite sure if this works, how this works. And I'm already taking it. I already like destroyed this roll once and I put it back. So, but basically the idea is just like to put them on the. Oh, actually, I added the test piece and I totally forgot. So let me just quickly show you. So I added this strip here just for testing, and then I forgot, which means it works quite well. Now, obviously, here's a bit too thick. Yeah, but these will basically add along the inner edge of the extrusions, just like to keep the heat in, keep the ABS smells inside the machine. So yeah, that was like one addition I made to that kit, well, not kit, but like to that printables project page, however you want to call it. Yeah, so it's one thing. Let's quickly also like go over the PZ probe and how that is going. So we installed the PZ probe last week. I printed all these panel clips, or quite a lot of like work. Also, let's quickly check these out. So the first layer is pretty good. Like it's very consistent. Like no matter which part you take, like it's a very nice consistent set. Maybe this one's a bit off, but they're all like they all have like good first layer. And that was actually really easy. There are two issues basically I had to figure out. One I solved partially, and one was just like getting used to how it works. The first thing is, it's quite obvious, you have to make sure the nozzle is clean. So I mentioned last week already, I want to add like a nozzle brush that is automated. The parts didn't arrive yet, so they will most likely show up tomorrow, knowing how that usually goes. So it's just like one day late. But at the moment, I just need to pay attention that when I start a print, I need to be there. And like when it's like the nozzle is like at 165 degrees, I need to take my little brush, and then I just need to scrub the thing. That's clean. If I do that, I get perfect first layers. That's one thing. The second thing is, we investigated last week the odd behavior with the when the tool head was in this position here. The probe would trigger randomly, and we thought it was caused by the fan. So it's not the fan per se. I mean it's caused by the fan, but the fan is like not the root cause. Let's put it like that. There were like three issues that I diagnosed just like from trial and error, just observing the thing. The first thing is I noticed that it's only happening on the front. That was the first clue. So it was only happening in these spots, especially on the corner, left and right. So that was the first clue. The second clue was that when I put my finger here and just pushed basically here on the top part of the tool head, the LED starts to like flash, like so it detects randomly stuff, just like not hitting it, but just like holding it. And while I hold, like it detects basically tabs. And then basically after some thinking and testing, I figured out, firstly, the bone tube and the cable were slightly too short, just like slightly. So I actually made a new cable. This is the old one. This is a new one, which is like like a centimeter long or something. It's not old. You also see I added this like random piece of bone tube. I don't have like a long part of piece of bone tube anymore. With the big inner diameter. So I just added this little thing. You see also here's like centimeter that extends that. It just prevents the bone tube from sliding all the way down. So it technically extends the bone tube by, I would say like 1 centimeter. And that's enough to just don't have any pulling force on the tool head. But I was also like a bit confused because like if I like move my tool head, and that's like something that's a bit hard to show on camera. Like you can feel it for sure. But if you like look at, maybe if I zoom in here, like really close. So if I now wiggle on this tool head, you see this, right? Like the tool head wiggles. And this was always the case for this tool head. On this machine, this was always like this. Like it was never like super steady. And I thought it was just like like first I thought it was just the tool head mount, but now we installed the CNC mount last week. And since we installed the CNC mount, I also had the vibration on the front, like when the tool had moved, like basically on the minimum, like here on the front of the bed, I had vibrations. I still have vibrations. And it's also like when I push here on top of the tool head, I have the same vibrations. So I think what's happening here is like that this carry edge is a bit too loose. Like this is not normal. I compared with two people having the same kit and the same rail, and they don't have this wiggle. Also, one person also had the same CNC mount basically, and that's not a thing. So I think my rail is bad, or at least the carriage is bad. So what I did now, I ordered like a new rail. There's something maybe next week we can put in and see if that improves things. So my expectation would be with the new rail that we don't have the issue with the weird noise anymore in the movement along the y-axis, x-axis in the front. And my assumption would be that we don't have the PZ probe issues at all anymore. Like still happens a bit, but like not a lot. I'm pretty sure that the rail is the culprit here. I did, Jordy. You didn't miss a lot. I was just like recapping basically the PZ probe, and it's working great now. And yeah, the main issue was just the bone tube and the umbilical wire were like tad too short, and that caused a bit of like pulling force on the tool head. And because my rail is not super like tight, that caused vibrations, and these vibrations then basically caused the PZ probe to continuously trigger in the front section here of the bed. So that was basically what I was talking about for like way too long. But yeah, besides that, it works really good. Like I'm really happy. Like it's great. I actually have the meshing now on, so I have the adaptive meshing. And for the print, it just does like it's a 3x3 adaptive mesh, and it's amazing. Like it just works. Like I have to pay attention the nozzle is clean, which is a bit of a manual process. I hope like once we install the nozzle brush next week, that this will be like automated, no brainer. But yeah, so far it's printing really good. Can't say more. Like it's printing really good now. I still have like a bit weird input shaper on the y-axis. Like it's not bad, it's just not perfect. But I also have suspicion that this tool head wiggle has something to do with that. So if I get the rail next week, I would do it in 2 steps most likely. I was thinking first just swap the carriage and see what that does, and like keep the rail. And then if that doesn't help, like I would just like swap the rail and the carriage. But I'm pretty sure the carriage is the problem here. But yeah, enough talk. Let's put some panels on. So, but yeah, I think step one, let's just take all the panels off. It's not too many. I actually have the back panel is not on at the moment. I have that over there. Because oh yeah, I also had issues. Like suddenly I had issues with the MCU disconnecting, like mid print, like with communication error MCU. No clue what that was about. I changed the USB cable that connects the Pi with the SKR Pico. Problem gone. So suddenly the cable was bad. I have no clue what that was caused by, but and was easy to fix. I have quite a lot of USB cables actually, so let me quickly make sure we don't mess up this very nice spool of filament. Okay, yeah. Oh yeah, for the panels, I think we will encounter 2 issues. One issue being the handles. I don't think they will fit after. So most likely we'll have to make a custom mod of these handles. The same goes for spool holder. It's kind of like my expectation is that we won't be able to use these anymore. So there will be some work for later. Let me also make sure that we collect all the parts. I guess we can just collect them all in my messy bucket. Actually, I think this panel should also stay in place. Let's keep this like top panel here for now. Let's maybe just give you like a bit. No, maybe this is the best view on this thing. But these go for sure. Yeah, I'm just curious how this will all align because like the parts don't look like they will like go nicely around the corners. So potentially my perfectionist self might not be satisfied with what we're doing here or with the outcome of what we're doing here. It's a first test, and then like we can improve it. The description on printable said like we can reuse all the nuts, which makes me very happy. Wait, there goes the first panel. It's always a bit painful with the V0 if you didn't have or don't have the preloaded nuts. There are the nuts that you could slide in later. That's still like a bit painful. Oh, there's actually one of these nuts you can add later. Not sure why we added that there. Not of nuts is working, is worth printing, but when you forgot a couple like me, you get annoyed by it. Yeah. It sounds like the ones I printed, the dimensions are not super well, or not super good. So basically they still drop, which is a bit annoying. They don't stay in place. I did not pay attention to it when I built this printer initially. And like you can still assemble it. Like even though they slide around, the no drop mod is like still good because it just keeps the nut to the front of the extrusion. I think I need a bigger container. Okay, that's all the parts or all the panels off. Okay. So let's also quickly remove this test strip I put here. It's too long. We can place a nicer one later. I have enough of this. We don't have to reuse or something. There's a bit glue residue, but we'll glue something on top, so doesn't really matter. I'm wondering. No, let's do the bad stuff later. So looking at this whole mess of parts, I think we should like get like a rough idea first, what goes where. There are a couple of parts that have hinges, so I think we can quickly maybe do those first. So this is a hinge part, because then we can see like how those parts go together. There is one hinge part. This is another hinge part. And I think they're different. So this one has holes. So I think the one with the holes most likely goes to the extrusion. And then the one without holes is the door part, I assume. So here's another one with hinges. And there could be one more. I made very sure to check that I print all the parts, which is quite difficult because they all look the same. I wish that there were nuts that you could place after. There are nuts you can place afterwards, Jordy. I know you use the square nuts that were included with the other. Yeah, exactly. The one from the LDO kit that I paint to screw into. Yeah. That's the thing, like the LDO kit comes with these like square nuts you can put in, and you can like use tweezers to like put them on top of this like printed part. But yeah, they're quite painful. I also don't like them. Um, so actually, I think I didn't miss any. I didn't miss any nuts when we built this initially. I do have like one of these here, actually, of these LDO nuts. Like here's one. I have no clue why I added that there. Oh, but there are only 4 here. So I did forget one. I did forget this one. Oh, and also like one thing that I noticed. I mean, again, it's not a big deal, but you see here, this is a no drop mod nut. And this one oops, this one broke. There's one part here and one part there. It just broke. Okay, so this is without holes, this is without holes. So I think maybe let's also just put this down and you makes it a bit easier to arrange nuts and everything. So this one should go here, I assume. And this one should go here. And then this gives us the two hinges here. So let's just start with these. Oh no, I actually have enough screws here because we only need one. Oh, potentially I wanted to do something else there, plan ahead. I don't know. But I think we do no longer have the middle clips. Like I only printed, we do have the straight ones here. No, but like the illustration in printables, which is like the source of truth, it doesn't show any middle clips. So I think it's only these really. Okay, let me quickly. We need to reuse the screws, I guess. So let's just quickly separate the plastic parts and the screws. And for the hinges, I think we need longer screws. Like looking at this, I think we need like longer screws for the hinges. So that's something we need to check in a second. Oh no, wait. Yeah, this screw is a lot longer. Let's quickly check how this is supposed to work. First to the sorting. It's also like these, you see like these have the glossy texture. I actually really like this texture. This is from the Creality glass bed. I actually kind of like missing this texture. I kind of like it. It's like this like square dot texture. It's quite cool. I still have the glass bed. I could technically use it with a different machine. I'm sometimes just getting like fed up with the texture of prints. Like I now used the Allsec sheet for a really long time, which gives like a satin finish in a certain sense. But you see all the lines of the first layer, which is, I mean, it's nice. But now I also really started using the textured PI sheets again. It just gives you like I also like the texture it gives you because it's like very uniform. You don't see the extrusion lines immediately. So yeah, I always like get fed up at some point and then start switching it out. Let's see. Yep. I don't know. Did you get files? Yes, I got the files and I printed them. I already advertised them. Here they are. I also put a link in the description. We'll quickly start with the panels. Just ordered my tickets for Printed Amsterdam. What is Printed Amsterdam? I feel like I missed something. Conference about 3D printing in Amsterdam. Well, okay, could have guessed it. I'll check it out. That seems quite local to me. Hope they work for you just as good as they work for me. I hope so too. The only thing I'm a bit concerned, I see the screws I have currently in the bed seem very short. Like they don't stick out on the bottom. Like here, there's no screw left. So adding these extra spacers, we might need to swap the screws. And then it comes down to if I have long enough screws. Looking at the frame for the project, just realizing how small it really is. So hard to see the size of Fusion. Well, you talk about your project or this project? me just put this over here and hope that I don't drop everything. Okay, this gives us like a lot of screws to work with. I'm not quite sure about length. Yeah, this is too long. I think we need very short screws actually. And this is already 8, I would say. I don't think I have a shorter screw here. No, in this bucket I don't have shorter screws. Let's investigate what our LDO saviors gave us to work with. So this is M3 by 8. Yeah, that's what we have here. So these are too long. And 3 by 6. Let's give that a shot. Oh yeah, my mini switchwire frame. I knew it was small, but seeing the size is comically small. You built the yeah, it's 2020 extrusions. I think that's maybe why it looks comically small, because you use 2020 extrusions in this size. Yeah, so the M3 by 6 work fine. So we have quite a bunch of these, which is good. But then we wouldn't have needed to strip all the screws from here. Okay, I'm also thinking maybe it's worth gluing the magnets first. That might be smart, because if I glue them here, we might like damage the extrusion with the fumes of the super glue. Let's just use this PV probe. So yeah, we only need to glue 2 magnets for now for this part. And then let's just make sure that we use the magnets all in the same direction. So what I will do is, like, I will just use the stack basically to place them. And on one end of the stack, I'll just put a dot. So now I just have to pay attention that every time I put a magnet, I'm looking at this Sharpie basically. Then I can just do this. And then it should all be in the same orientation. And then later for the panel, it needs to be the opposite. So basically, I must not. We need to put like a marking on the other side. So and also what I noticed, the bomb set like the 6 by 2 millimeter magnets, but these are like still like, this is 2 magnets now. And you see, like, it barely sticks out. So maybe 3 millimeter would have been better. And also something I noticed, we need to pay attention that we don't put too much glue, because there's a small hole that you can push the magnets out again, I guess. If you put too much glue, like it oozes out. So careful with that. Okay, I think for our 2 dummy pieces, that should be fine. Let's put them on. Let me actually see, do I have like a container where I can quickly like pour out a couple of these screws? It's full. Where can I dump that? Ah, I'm not having any containers. This is sad. Okay, well, then we have to take them out of the bag one by one. Okay, that's one. I was like, oh, where are the nuts? That's the wrong extrusion. Okay, let's do the four corners here, and then do the panel, and just see how that works out. So I assume we need we can just go by what seems to fit, which seems to be this part. And this part, I guess. Oh no, this is the same. So we need a mirrored version of that. This one. Let's quickly glue the magnets. Looking at the marking. And no glue on the back, so. Oh, I'm missing a whole conversation here, see. Massive amount of leftover screws and nuts. I have to install. Yeah, well, it's actually really good. Like, because if I do like mods like this, you know, like you always find something in there. It's really nice. And I kind of like the idea of just having like one type of screw in a machine. So it's just nice to have like these screws everywhere. It's really good. Like, I mean, also to be honest, it doesn't cost a lot of money to just like throw like a third more hardware in such a kit. And the LDO kit is quite pricey compared to the others, so I also expect some extras in a certain sense. What's the purpose for this small printer? Welcome to the stream, Tilo. Sorry, I totally missed you. The purpose is to print stuff. Like, if you do some self-reflection, how many parts do you print that are a lot bigger than this machine? So most parts I print personally are within the print volume of this printer. And the benefit of having such a small printer is it's extremely quick to fire up. There's not a lot of meshing going on. There's no, sorry, my voice is kind of dying. The bed heat's super quick. The tool head is very lightweight, so it prints very, very quickly. And it's just like a very nice machine. Like I love this machine. For example, like all these parts are printed on this machine. They all fit. Also, like if you want to build like a bigger Voron, all Voron parts that are essential can be printed on this machine. So if you, for example, want to build a trident or something, like all parts of these printers fit on this print pad. Just really, it's a beautiful machine. Like in general, I really love it. Like it's very small, doesn't take a lot of space. It's very fast. It's nice to use. It's really nice machine. Um, I would say its purpose is to print small ABS parts for other printers. Yeah, that's exactly the purpose. Like the guy who designed this, his task was to print or like design a machine that's capable to print other Voron printers. It is a bit painful, to be honest. Like if you want to print, let's say like a 2.4 or something with this machine exclusively, it just like you can only print like 2-3 parts per plate. Compared to if you would use like a larger machine, you can like make a big plate and print like for like 20 hours straight, and you have like half the parts in one go. A magnetic panel in the back. Thank you. Now I know what I need to change for my Warren. Let's see how it works out. Let's see how it works out before you. But yeah, I was really like, I was looking for different panels because I was annoyed from taking them on and off. And I was like, I don't want clips or something. I was just, magnets. I like magnets. Magnets are magic. Cool. So these are all on. And this is a very, I mean, I really need to clean those. I also feel like there's like some stuff, like on the outside, they're very smooth. And in the inside, they're like a little bit rough. So I feel like it's like the ABS dust and everything settling slowly. So maybe I can just like polish them as well, just get rid of all the stuff. So this is kind of like how it's supposed to be here, I guess. So we have the. Let me just make sure that this is. So we have these corner pieces. We just need to make sure, like the ones without magnets are for the door most likely. Um, so I assume this fits like this, and this has a magnet hole here. So this. And then there's one with open. I'm not quite sure where this one goes because like these have like the corner here and this one is open. So this might be special for something. I don't know yet. There are quite a couple of these open ones. Maybe we should quickly investigate how this is supposed to be. This one again has no magnet, so I'm pretty sure this is for the door. Let's just collect all the door parts over here for a second. And here's another one that goes like here. Yeah, there are a lot of these open parts. I assume this one was here. So technically we could put this in, but before we glue these, let's just double check that we put the right stuff together. Screws are easy to undo, glue is a bit annoying. I mean, you can buy a bigger printer for the same or lower price. Well, you can technically, but then it's also less capable, right? So it depends how much you want to pay for a V0. I think the cheaper kits start at like 350, 400 euros. And yeah, of course, you can get a bigger printer, but then it's a less capable machine. This is a fully enclosed machine. It's extremely fast, which most bigger printers at that price point are definitely not. Um, and it's basically your printer. There's always the thing, right? Like, of course, you can buy like a Creality machine or something for like the same price. I think like in this price range, you would maybe get like an Ender 3v3 or something like that. And of course, they're cheaper, but it's also like a less capable machine then. And yeah, this is what you built. Like I have like a very close personal relationship to this machine because I spent a lot of time and effort building it. And for me, it's just like way more fun working on this machine than just having like a stock machine that I don't touch. So yeah, like you can't really argue with the logic in certain senses. In certain sense, like you can make an argument it's a capable machine for like reasonable price, and what you don't get then is the size. Um, but then on the other hand, it's also like just the joy and fun building the machine and making really like your own. I didn't know the Boden came out of the foot. Yeah, there's the Boden. It's actually like technically there's I'm not sure if I can pull it out because Boden is quite slippery. It's a short piece of Boden, and then you have the filament sensor inside the foot, and then on the backside there's the second Boden, and this one is just there to protect the printed part basically. Okay, let's quickly check the printables thing. We don't have a lot to go here. So this looks roughly like what I am seeing here, right? So we have these parts, I assume. Yeah, so this is what we have, right? This looks all good. I'll just go for it. Like the backside for me is a bit more of a question mark because we don't have any pictures of that. We do see here a tiny bit the straight pieces, so Which also makes me then one. Oh, the straight pieces for sure are for the back. Okay, check. And I think these pieces with the open end most likely are on the back side on the bottom. That would make sense, but we have way too many for that. Yeah. We'll figure it out. Let's just do the first thing. Let's also quickly check what they say, how to put it together. Yeah, and they use tape to put the panels. You need any extra nuts and bolts? Yep. Yes. The files with frame and the name are screwed onto the frame. The ones with panel clips are going onto the panels. Okay, I don't know which parts we have now. The whole fitting's are magnetic. Otherwise, yeah, it's all fine. It doesn't explicitly say what to do with the tape, but I assume just to tape the panels. It's always how to say, hobbies like to build printers, others want to print and buy pre-built machines. Yeah, of course. I mean, like, we had the same with keyboard, the discussion with the keyboard. I fixed my keyboard, by the way. The discussions with keyboard last stream, right? Like, where we said, like, yeah, of course, like, every normal person buys a keyboard. But then there's, like, these, like, enthusiasts who just like to build their own keyboard. It's exactly the same with printers. Like, I just want to build my own printer. Let's just quickly prepare everything maybe down here. And just make sure that the rough side goes back in, that we only have one bad side. So I think all we need is like small... You are not supposed to be here. All we need is like very short strips here on the inside. But also should not be like thick tape. Like just looking here, this is quite smooth. So I'm actually because this is like let's quickly use this one VHB tape. But this is like it has some height to it. I have a different tape that's flatter, so maybe the other one is a better choice in this case. Oh, the joy of VHP tape. Yep, I think we are getting lucky. Quickly check, because this is a bit taller than it's wide, so it needs to go like this. Oh, immediately did it wrong. I mean, this would work, but like the panel is now a tad thicker. I'm really considering to use the other tape. Let me quickly get the other tape, because also here, like, we are a bit limited. I mean, technically we could add a bit of tape here in this small section, but it's a bit annoying with VHP tape. Let me quickly grab the other tape I have, and also let me quick some kitchen towel. Then we can also like clean the panel where we want to tape it. Hi there, Harlem. Let me quickly pause. Hi there, welcome. Um, How did you fix it? Well, how did I fix it? I fixed it very, very easily. In the end, like I did exactly what I wanted to do. Um, 1 second, I'm trying to kill my music. Um, I fixed it exactly how I wanted to fix it. Like I just like unsoldered like 5 keys, and I unsoldered 5 bad keys, and I just swapped them. The awkward thing is like I also cleaned it, right? Like you take apart the keyboard, I just like cleaned it, and then after I put everything back together and like assembled the keyboard again, all keys worked, including the ones that were broken before. So I think what happened is there was just like dust or something like in the key action. And when I like turned over the keyboard and like gave it like a proper knock and like cleaned out the keyboard with a vacuum cleaner, it just cleaned the keys and everything works again. So I wouldn't have needed to desolder everything after all. But so better to have like fresh keys in the most used spots. Okay, so this is like very thin tape. And what we can do is we can actually just tape it in here like this. And then I will just use a knife and literally just cut it if I have something to cut on. Do I have something? No, let's just use the box of the sealant tape here. And we can just literally, oh, actually it's quite good. And we can put it here flat and then just do this. And now we have like a perfect taped area. I think that's the best approach. This should give us the most like area. Oh, I forgot the kitchen towel. I knew I forgot. Like you don't see it from the outside, and this should give us like it holds way better than the VHP tape. I'm just not sure like how heat resistant the tape is. So if the inside of the printer gets hot, maybe this loses like the adhesion. Let's just see how it goes. And also see like I need to pay attention. Like this is not properly in the corner here. Um, let's just see how this goes. If I like those panel clips, I'm also fine with just like using like proper glue to glue them. Okay, let's just do this like 4 more times. And then we also need to quickly glue in the magnets. Oh, I was like, where's my tape? I have a lot of like small bits of the tape flying around here, but maybe I can try to collect everything in one spot here. Nope. I just need to pay attention to not cut the, the part. Okay. Let's go for it. This goes here. Make sure to have this all the way in the corner. And this goes here. This goes here. Oh god, this will be such a mess. Okay, so all we need is magnets. Let's just do a quick check. So now we need to have the opposite direction, I think. Yeah, exactly. So where we have the marking now, we need to put it down and then we lose our marking. So we need to reapply it. Just adding a tiny bit of super glue. Make the magnet fit very loose. It's also like what it says in the printables. But I would have preferred it to be like a bit tighter. I'm not sure if like if we now flip this over, most likely something I learned. Super glue is like activated by moist air. So if you breathe on it, like it cures very fast. Let's see if this is. Well, it works. It's not super strong. I would have maybe wanted like twice the amount of magnets, but it works. The magnets are glued. And Alex, I'm worried because those look like small magnets. They are small magnets. They're 6x2. So I think like this should have just have two per clip. That's why I love binding fingers together. The worst part is, and like some like there's some pictures and videos about that. People get super glue on their fingers and they try to use water to wash it off. It's like it does not work at all. It just makes it worse. I mean, this is kind of okay, but yeah, it's not perfect. Let's roll with it for V1. But I think we might want to like mod these clips to just have more more magnets, maybe like even 3 per panel. Um, that being said, we also have this foam. It's complete mess. I'll just take it from the center first. We have this foam here. So I would just add the foam here on the inside. Okay, so this is not how you do this. So we have the foam lip here, and this should. Ha! It's not enough. It's not enough. Um, there's still a gap. Let me just quickly like. You can still see if I maybe put my finger here. You can see my finger, right? Like from the bottom. Yeah, I'm just lifting the panel a bit. So there's still a bit of a gap. It's not enough. Like I think it would need like another 2 millimeters almost to close this gap. So let's install the foam. It's better than nothing. But not ideal. Let me quickly check what happens if we double foam it. Like if we now put foam also on the panel here. I assume now it's too much. Yeah, no, just it's all the panel as well. Like I had the same thought. But now the magnets are not quite strong enough to pull it down. Like it works, but also now you see the tape here, which is not nice. So if we do this, I think we should just foam it like this. That we put it like on top of each other here. Oh, I put this too far out. I think this is not definitely too tall. The other option is that we just use taller tape after all. Yeah, because here's not quite a, like if I now double tape that, so you see here's like the double foam till here, but now you see there's like a gap here. So this is definitely too thick. Let's try one more thing. So see if I can carefully remove this here again. Let's try one more thing. So we now used the very flat tape. We will have to redo this one corner. Let's quickly try if we use the VHP tape instead. Let's just apply this in the same way that we kind of like have a strip down here. And then we just like cut the excess. Just it being VHP is a bit harder to cut. Let's maybe see. I think this might be a bit easier with the pliers. Benefit, now we have a very nice latch here to pull. Oh, first attempt needs to be in the right spot. Let's try again. Maybe we can put this back. Okay. Okay, so this is definitely making it thicker. So potentially this solves the problem. It's not quite enough. Like that should push down the panel, the acrylic panel. But if I feel it correct, the panel just sits on the bottom part here. So that's not the issue. I think it's just like that the foam tape I have is not tall enough. So let's do the following. This one is 6x3mm foam tape. So I think what I need is I need 4mm or 5mm foam tape. So it's something we just need to reorder. Don't the straight bits fill the gaps? Which, you mean these straight bits? I don't think they're supposed to go there, Steve. Because if I look at, where's my, oh, I'm looking for a mouse. If I look at the pictures here, I mean, the straight bits, I don't think they are size-wise that they fit. Like, there's still like gaps, which also could, by the way, be like a way to like improve that magnet force, right? Like if we add more parts here, we could just add like one long part here because we still have like one nut on each extrusion, right? So we could add one long part here with one screw in the center and then just like indicator thingies, and then just have like a couple more magnets here. That could also solve the problem with the, it's like not like super strong. The other thing we could do, technically, if we double tape this, double tape, and then we double magnet. So if I just put like 2 more magnets here, I mean, now it's closing. It's just like now here it's like quite a big gap. So it's, that doesn't look nice, but that would work. I think it's just like I need like another foam tape. Oh no. Now the magnet wants to stay here. So I think it's just like I need different foam tape. I just need a bit taller foam tape. I think the mistake I made is I measured the part and was like, oh, it's 3mm. I need 3mm foam tape. So I think I just should have added like a bit more. It's not a horrible gap, so I think it will still be functional. But then I think solution one I actually like is like adding like just the printed part here to improve the magnet force. And the other option would be to just get different foam tape. Let's just install the foam tape we have for now. It will prevent the heat from escaping, so I try to install it like this, and I just like peel the backing off as I go. And at some point, you just snip it off. And I think I was just too optimistic with my foam tape expectation here, like from the thickness. Right? It doesn't look bad. But it also doesn't hold very well. That's like my main concern. Like this does not. Just feel if I screwed up a magnet. No. Like this, like now holding it like this, like it already slides down. You can always change it. I can change everything I want. I think this is like not super suitable, to be honest. Because now if the printer moves, I don't think this will stay on during a print. It's just not enough magnets. I mean, or my magnets are bad. Maybe my magnets are bad, but it's about what I expected or would expect from these magnets. Um, let's quickly check if we can, because we have these straight sections as Steve mentioned, but we don't have corresponding straight parts from the extrude from these corner pieces, so we can't put them here in the center. That would be like one thing we could do. Oh, that really sucks. I was really looking forward to these magnet panels. Yeah, they won't hold on. If you print something too fast, the printer will lose some weight. Exactly. Yeah, that is exactly what will happen. Um, yeah, I would say this is kind of like a failure, to be honest. Because if I now put these on, like if we continue this and I put them on, I think I will have like a non-functional printer in the end, like for ABS. So this is definitely not going to happen. So I think Alex, your worries were justified. Can you add magnets to rails? Yeah, I was also thinking that. But it would be like a different designer, right? Like I don't have something to add magnets to the panel. The panel only has the 4 magnets. That's how many magnets we have here. So I think we have two options here. These panels will not go on. I think that's the decision. Because I need a functional printer. Um, that's quite a bummer. Let's quickly see if we can come up with a better design. So one solution is, of course, to just add more magnets. We can easily add 3 magnets per corner. I think another problem is that comes down to like the depth of these magnets. So the design was made for 6x2, which maybe 6x3 would have been better because you have more magnet. But also, like if I push them in here, like you can push them in like quite a bit deeper. If you look here, like you see that there the magnet is like it's not flush, it's below flush. And that's quite a problem because like the magnetic force will of course diminish over distance. So actually what I usually would want here is for these, like if I push in 2 magnets, you can see like it's standing out a bit, like just a tiny bit. And this is obviously also what you want, but now at least the magnets would touch directly. And if the magnets touch directly, they're just like stronger. Um, that weakens so much. Yeah, exactly. Like it's really like a very narrow distance, but it makes a huge difference. I think like I paid attention to glue these like flush. So this is not a problem here because here they are pretty much flush. But still, like it's better if it's just like properly touching. So I think that's one option. We just add more magnets. Um, but then, like when I was thinking about making my own design, I was also thinking exactly what Neo was saying. Like, can we add magnets into the rails? Um, and that would mean, like, if I look at this extrusion here, so the opening we have here is 3 millimeters. I mean, first let's just try what happens, but I don't think we get like a 6 magnet in here. So you would need to, like, if you would want that, you would need to preload them from the side, which we, for the V0, like, it's not really like doable. I mean, it would be doable. The main problem would be the bottom. The bottom. What do you have in a washer behind the magnet? Would most likely work, to be honest. Like, if we add a washer and then glue it, should be fine. But again, like, I glued them flush. Like, they are not. These are fine. Um, but it's not the. It's just not enough magnets. Like, you need more magnets. So I kind of like the idea of preloading the magnets, to be honest. Because then you don't need these parts. It's just flush. So you only need the parts on the panel where you can add the magnets. You know, like, it's such a nice idea to have like the panels just magnetic. It's just like the part here is not really nice. Let's see. So technically, like, if we have a smaller magnet, like, if you would like to preload them, right? Like, the extrusion here on top is quite accessible. We already took it off like last stream. It's very easy. You just remove the cam lock, screw on the back. You can remove this top extrusion. Easy. I think it's also relatively easy to add magnets to this one here. But I think the one on the back might be quite a pain because then you have to remove the entire motor. And this on the bottom is also like a no go. So I don't think we can preload them. Um, I really need to come up with something as well, because I want that for the back panel. Yeah, like, the back panel is also like magnetic. Like, there are also parts for the back panel here. Maybe we can quickly check if the back panel holds better. But I think just looking at the parts, it's very similar. So it's these straight parts here. It's these straight parts. Also for the back panel, like, you would need more nuts. Like, there are only 2 in here by default. And then it's these, so it's also only 4 magnets, so it will not hold. This will not be better. Um, at the top. If you're going to design a clip, make a drop-in slot at the bottom and magnet clip at the top. Yeah, I think it's also like a good idea, Steve. That you mean basically that you have to like angle it like this, like that it hooks into the extrusion, right? That you angle it like this and then drop it in, so it's like vertically supported. I think that's a good idea. Technically, you could also just add like little features here on the plate, just like a little like knob, basically, that comes out. That A holds, right? Like, if you would have like a little knob here, like a little like pyramid shaped something, and like the matching part here. So firstly, like, the magnets would locate it, and this part would like give it like extra stability, right? Like, here it like really wiggles around. But if you have like some 3D structure basically that connects the 2 parts, like in some way like this, like, you get way more rigidity. Um, and you could technically, like, there's nothing preventing you from adding like such structures here. I like the snap latches on the Voron 2.4. I think I have, they have Voron 0 version called Voron 0 filament latch. They snap close, no magnets needed. Yeah, that's also like option, Alex. Like, I was looking at a lot of different ones, but I really like the idea of magnets. It's just like, I did not consider that the execution here is not as good. You can use the small standard parts from the middle and put them on the bottom. Technically, I could do that. No, that's an excellent suggestion, but I think they don't fit. They don't fit because now the panel here is higher than before. So if I put the part here, um, there goes my screwdriver. So if I put this part here, there's this much space below. So this will not work. And it's actually the same issue I mentioned before we will have with the spool holder. Because also the spool holder has the same issue, so it doesn't connect anymore. And more magnets, I think you can use the slicer and add negative part to make the magnet impression. There are step files for that. So the question I have just is like, do we want to build off this design or do we want to do something completely new? Because then I would just convert the stream into like a Fusion Fun stream. And we just continue with that. The only thing I quickly want to figure out is if I like the parts themselves. So this connects somewhat okay around the corner here, so I think this is fine. And I don't think it covers this piece here. I don't see how this would work out. So I think we can modify these parts to make them better. For these parts, I don't know either way I need two screws, to be honest. But that's how it's designed. It's actually like quite a problem because you only have two nuts here, and you only have two nuts here. Like technically you have three nuts here because of the spool holder. There should be actually four nuts here. There should be four nuts here. No, so we only have three nuts here. Interesting. Okay, let's put the old panels back on. That's not gonna happen. I'm very sad. I was really looking forward to that. Okay, let's do it. It's good that we took off all the panels in the beginning. So let's do the following. We put the old panels back on. Then let's look at the Fusion files. And then I would just like change the panels to have like 3 magnets each. I think if we have 3 magnets per, or like not like per clip, then we would be quite good already. And then I would also add this like 3D location feature because it just gives it more stability. So the magnets, like if you have magnets, like from the pulling force, they're quite strong, like even the small ones. The problem is like the sliding. They're quite weak for the sliding. So if you give the magnet support in a certain sense, like for example, if you look at my knuckles, right? Like if you have the pulling force is quite strong. So if you have like my knuckles basically like lock into each other. If you have something like that, the magnet only needs to hold the pulling force, but not the sliding force. And this will make it a lot stronger, even with the small magnets. So if we add more magnets here, so let's say one here, just 3, it will be very strong if you combine it with like some small feature to hold in place. Okay, let's just start with the electronics panel. Then I think we're not going to check out the LEDs today. That's a bit of a shame, but we only have so much time. Well, now we can figure out how it goes back together. These are the clips for here. Yes. I think one of the least successful endeavors I ever had on my channel. And that's saying something. Okay, then on this side we have the spool holder. I was wondering, like, maybe this really only has the center here. Yeah, but then the other part is basically like, I expected that I have to design a spool holder for this. Oops. Ooh, careful. Would love to love a design where the panels would be directly on the rails. I think that would look the cleanest. Yeah, I think for sure. But then, like, if we would do that, right? I feel like there was something here on top. I feel like I'm missing something. Let's see. We'll just do the panel clips back one by one, and we see if something is left. Um, if you do something directly in the panels. Where are my magnets here? I don't think we have any open end extrusion here. Oh, here we have. So technically what you're saying, Neil, is you want it to be, I mean, this is quite a challenge, but you want it to go in like this, right? I don't think this fits. You would need like smaller magnets. No, like these don't fit in here. Like they're too wide. This doesn't work. Like it's ever so slightly too narrow. I think these are 5 millimeter. Where did I have my calipers? Like the opening here is 3, and then inside 5/8. So the 6 millimeter magnet is just like barely too wide. So I think you would need like magnets that are 5 millimeter wide. Yeah, it's really annoying. Like it's just like barely too wide. So you would need magnets that are 5 millimeter wide. Just like eyeballing it here, like 3 millimeter-ish tall. That they completely slide in here, and then you would still need something to hold them in place because you don't want to like want the magnets to slop around in the rail. So if you would look for bar magnets, let's say like a bar magnet with 2 by 4 millimeter and then times 10 or something. You have like a bar, then you could like print a part around that where you can push in the part into the rail. The parts you just use, if you glue them to the panels and change them that magnets or flathead screws can fit, you might be able to get it right on the rails. But I would still need something in the rail, right? Like either the magnet or the flathead. Or am I missing something here? flathead would be easy, like a flathead in the rail. Am I understanding it correctly? So you would use the, oh, sorry, I'm showing. So you are saying, because we have the nuts here. This is a M3x4. Amazon does have 10x4 with 2 magnets. Yeah, I think that would be like one option. The only problem is with this, Alex. For example, like if you want to have the magnets inside this rail, you would need to remove the foot to like feed them in. Um, so it's just like a lot of disassembly. It's not really like drop in. So I think, I mean, we could do this. This is the best I can do now. Um, but I'm not sure how strong that connection would be. Because like it's less strong than the magnet on magnet connection, I think. And also with this is not directly on the rail because the flathead on the extrusion because the flathead stands out a bit. And it's not like it's like doesn't hold a lot. And if we do this, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 11, 12. Should be 12 magnets total, which is a lot more than 4. That's rough for work. Good luck for build. Thank you, Alex. Good luck with work. um, but Neo, this is what that's what you thought, right? Like to have the flathead here. I used to connect in a different situation, but the nuts and screws are bigger. I was hoping it could work here as well. Technically, it could work because like this is standing out a bit, which gives us that 3D connection I was talking about. So if we could, here's the trick. You know how I said like this one is a bit deeper? Right. Let me quickly get one where we, okay, -1 magnet. Let me quickly get one where we glued it in. So, mm, here it didn't, let me quickly check. I didn't glue the magnets in all the way. Quickly get one without. Let me get a magnet. Remember how I said there's like a bit more depth to that? So if we, this looks actually quite good. Let me quickly glue the magnet at full depth. Okay, so this is now all the way in. Let's align this. This could work. It's good that I already removed them from all the from our test panel, but this could actually work. It doesn't work here because here you need a door for the hinges. That's actually one part we need to consider because these parts now hold the hinges. So if you don't have this part, you would need to find a different setup for the door. Well, let me quickly get one panel again. If we quickly, just for trying it out, I'm just pushing this magnet down. Just for trying it out, but then we would need to get rid of this foam here quickly. Yeah, with the foam, there's it's not touching. So let's get rid of this. I think we wasted like already like over a meter of this stuff, and like we didn't install like single panel. So if we quickly tape this, doesn't need to be pretty, just for trying it out. Like, oh, but also you with these parts at least, like this one we can't use because the magnet's in the center here. So this is not gonna work here. We need this part. Yeah, no, it doesn't really. It doesn't really locate itself like on the screw here. Ah, here. Oh, that's another problem. Neo, with this magnet here, there's one problem we have. The panel, it doesn't go over the slot, like from the width, like you see here and here, but it's very close. So if you have a magnet here, it will be very hard to have it directly on the screw. Just from how close it is. You see the screw overlaps with the panel here. Like there's an overlap. Yeah, I know. The panel is in the wrong orientation. It was just like for me to try to whether this could work. But yeah, I don't think this is going to work. So let's just put on the old panels quickly, which is something I didn't want to do anymore. So now I can do it again just for fun. But then I think if we want to customize these parts, more magnets is the way to go. And just like throw more power onto the problem, basically. Bummer, yeah, definitely. It's not how I expected this to go. I mean, like, there's no makes of this mod on printables. which I thought like, oh yeah, maybe it's not that good, but I expected it to work better than this. I expected it to be better than this. Okay, so then the panel goes here. Let's just check this the dirty side. Put the dirty side back in. Then let's do the following. Let's put it back together and then look at the bad thingy. I hope I hope this is more successful. And if that goes well, maybe we can just use a bit of time on the stream and just like jump into Fusion and see if we can mod these parts to be more functional. Then no, we need to. Are these the right parts? No, these are the wrong parts here. They go on top. This goes here. I did it wrong. Then, oh wait, this one also needs to be a special one. Where's my parts? These are all the new panels. Luckily, I didn't remove these yet. This needs to be a part with a hinge. Oh, where did I put these parts? Ah, I put them in here accidentally. Well, that will be fun. Here, there's the part. So that's the one with the hinge. Just another quick question. What type of filament did you use for the guides? ABS. ABS filament. I hope it's fine because like it gets quite toasty on the bat. But I mean, ABS is the only filament I have that is like somewhat capable of those temperatures. But it's also like it's not a structural part, so even when it gets like warm, right, it should be fine. It doesn't have to bear any load. What filament did you use for those hinge parts? Not hinge parts for those guides. There we go. Oh. That's also fun, right? Like taking off all the panels and putting all the panels back on. No, that screw is too long. Which screw length did we use here? This. Okay, that was one panel. We already did the panel on the back. Then we have one for the front here. It's a random M3x6 screw we lost. I bought Fiberology PA12 glass fiber, and from Printcore I bought a sheet for that. It works like a charm on the Voron. I actually never worked with any of these like specialty filaments, like with carbon fiber, glass fiber, and stuff like that. I didn't really see the need so far, and I actually don't have any abrasive resistant nozzle. So that would be like one thing I would need to buy first. Almost there. I had a big city tours. You're just in time for us being almost done putting on the old panels again. That was quite a negative success. I think that's all the panels. Oh, we forgot the handle. Okay. I do have one corner piece left. Ah, because we forgot one corner piece on this side. So wrong screw. Well, it's the only screw left, so let's. See if this works. Oh yeah, there's a marking here. Like it's actually like this is too long, the screw. Let's quickly grab a fresh one. And 3x8. Before that I didn't as well, but the Rabo high flow nozzle are so expensive. I thought I bought a hard one. Yeah, actually, like my thinking was the exact opposite. Like I didn't want to spend even more money on the Rabo nozzle, so I didn't buy a hardened one. Um, because I also had like one of my Rabo nozzles, like the non-high flow one. Um, this one's just cursed. Like something got in it, and I don't get it the clock cleared out. Like, it's not fully clocked, it's just like unreliably, just like randomly clocked. And then like that turned me quite off from spending like a lot of money for Rabo nozzles, because like like a nozzle can go bad, and then like you just waste a lot of money. Oh, we forgot the super long screws. We forgot the hinges. PA12 on small parts prints exactly like ABS, just calibrated with Orca slice, and it should work for you as well. Yeah, but then like for the I still need a hardened nozzle, right? Still need a hardened nozzle. Because like the last thing I will now do is like print abrasive filament with my non-hardened high flow nozzle. I do have like this nozzle. This is the one that like has like random clogging issues. Um, I could say I sacrifice it for like some parts with abrasive filament. There's also like if you use a brass nozzle with abrasive parts, it's not like it immediately goes bad. It will go bad within like let's say like a couple dozen of printing hours, but like not like immediately. But you could always just use PA12 without glass fiber. Help me out. PA12 without glass fiber is not abrasive, and the properties are better. It's like more heat resistance, I assume. Okay, it's back together. Let's check out the parts that Neo made. So my main concern is, and I think the problem is that I added these nuts here. Let's quickly just take the bed off and see what happens. Because I made like quite weird setup here. So I have the wheel, I have a washer, then I have the kirigami part. Shuffle the printhead around a bit. Oh. So we have the thumb nut and a washer on the bottom. Yeah, and then I added like the spring. And then for whatever reason, I think my thing was to hold the screw in place. I added the M3 lock nut. I'm not quite sure if this M3 lock nut is actually needed, or if this is something I added on the flow, on the fly. Um, because like now, if I add your parts, Neo, the problem we will have from that is that the screws will be too short. And I'm actually not sure if I have longer screws. Actually, like I have a bit hard time getting them out here. So I think if I pull the screws out, I most likely will damage the magnetic sheet. So let's try to live with these screws. So just like checking the thickness here, if we leave the lock nuts out, it should be fine. So I think we'll just leave the lock nuts out because I've never seen like lock nuts used in such a place before. And let me actually, we should be able to unplug that. You don't need lock nuts. I at least use normal ones. But you have nuts on the bottom of the screws. Okay, this should be all the cable connections, and now we should just be able to. They will fit in the parts. Oh, I did not see that even. Yep, there's. Okay. Woo. This is literally the first time I ever took out this part. Oh yeah, I see, I see, I see, I see. Why is there corrosion on my It's not corrosion, it's just dirt. Okay. I see what you're saying. So the lock nuts can stay, and I think the lock nuts will fit. It's just. So this should then. This one has. Yeah, but then it's also like I have then no concerns whatsoever regarding temperature because like all these parts need to do is like not melt, and they will not melt from 110 degrees. They will get toasty, but they will not melt. By the way, it's very satisfying snap. I like that. Let's see, we need to rotate that screw a bit. Oh, this one doesn't snap as nice. I have a ballistic tech. I have upside down lock nuts on mine. Yep, I also have the lock nuts. So I think there was in the manual. I think that somewhere says to use maybe the LDO one. Yeah, it might be just something that the LDO kit does. Or I was just like, oh, I want to use lock nuts. That's also possible. Put the guides on. Oh, push the hex nut in and then screw back in. Yeah, well, it would have been easier, but it worked out. The lock nuts might prevent the springs from pushing on the guides. Right? I think it's more about like securing the screw in place. That like when you change, like use the thumb screw on the bottom to like adjust it, that like the screw doesn't rotate. I think that's the only reason you need them. Because for example, like the switch wire bed I have, it doesn't have any nuts here. Like it just directly has washers, and then it has the springs. Okay, then I now have like random washers flying around. I don't think we need the washers. So then we have the springs. And now, you know what? One second. I do have. No. thought I have 3. Why do I only have 2? Okay. That's the end of this idea. Okay, well, 2 is not enough, but I was thinking maybe we can just use the silicone parts here, which are a bit stiff, because now I have a probe, so I don't really need to adjust the bed as precisely. No, but I don't see the last one. No, also not here. Nope. Okay. Well, then springs it is. Springs it is. Oh, I forgot to put this back. Okay, I'll put it back later. So technically, beautiful. Yeah, it's such a small thing, but like it really improves the usability of the printer. Just like very nice. Thanks for the suggestion, Neo. I like this a lot. And I think I soon should like swap the side. Like there's like the PI is like a little bit damaged here. You see like the little specks of gold. So soon I will have to flip it over. Okay. Let's leave the washers are definitely not LDO. So that's just our V0 spec. So let's just leave them out. Yeah. I was thinking like maybe we can just also install without the washers, without the springs. And then just let the probe do the probey thing. And let's just put it back the way it was. Minus the washers. Okay, let me just flip this to its back. This is still on, so we only lost 1 spring. And then maybe this is a bit easier to put this back. That is 1. Just move this as high as I can, so I can like reach in here. You know what? We should have done it before adding the panels back. Please use the springs if possible. They keep the guides in place even more than just the hex nuts. Okay, springs it is. I have a different bed line mechanism I've been working on. What's your idea, ballistic tech? Okay, so we don't use the M3 shims here. I lost. I might have lost 2. Oh, wait, the cabling. So the only problem is, I now pulled cables out like a maniac, and I'm not sure which cable goes where now. So the heated bed cables are no biggie. That doesn't really matter where they go. So that's fine. But the thermistor cable and the LED cable, because there's the LED on front. Make sure everything is in. For these two, I'm not quite sure. I think the thermistor was on the outside. Um, it's based on the 516C, but it has two small screws along the back of the end. Oh yeah, that's like the pusher mechanism, like the i3 plate has the two, right? Fuzzy bed plates have the grooves to slide into them like pusher beds. Oh yeah, like pusher beds. But it works with regular bed plates too. Yeah, that's nice. It's just like already if you have like a end stop, basically like at the end something to slide the ends, it already it's like a massive help. Um, I think the LED is here. Let's quickly do the following. And just quickly check out the LDO docs. What cable goes where. Or if somebody paid attention and can tell me, that would also work. Man, it's like every time like I flip this printer over, there's so much like crap inside. All the foam band we wasted. Um, we'll look at my printer. No worries. Let's quickly check out the LUX. Um, oh, it doesn't want to. There we go. LDO Voron 0 docs. 0.2 kit. Let's quickly check here. Kirigami Bad Guide. Let's quickly check. Oh, this is like a very nice guide now. Like they improved it a lot. Like this did not exist. I remember we struggled quite a bit. Yeah, this is the part basically. So the thermistor wires on the inside. If that's wrong, Clipper will tell us very quickly. Right? Yeah, thermistors on the inside, thermistors on the inside. That's just like upside down, but this is a very nice documentation. Like a very nice documentation. Very nice. Cool. Yeah, well, then this one did not work out. Potentially that's why nobody posted a make ever. Oh, I'm clicking the wrong screen. I wish I had when I built mine, but I had your stream. Yeah, well, I hope I could help, but yeah, I struggled a lot. I also printed the wrong parts in the beginning, I remember. Like, that was really, like, quite tough, especially because, like, the Kirigami parts just changed when I built it. It was, like, the old parts in the LEO guide, but then were, like, the new parts, and it was really confusing. Yeah. Okay, well, this is then... I mean, this is a partial success. This is a partial success. Let's quickly turn it on, make sure the bed is properly installed and everything. I printed everything and had some left as well. Yeah, I also printed like the old parts and the new parts because like not all of the new parts, not all of the old parts were replaced by new parts, so you still need some. It was very confusing. Door. Yeah, the only thing is like for the magnetic panels, I'm not really like in the mood of having like another cat project I have to like design myself. I'm a bit short on time at the moment. It's just, I have this like really weird like part here, which is metal. I have no clue what this is. It is a metal part. First thought it was coal. Okay, weird. Um, it was here on the magnet of the Nevermore. Oh yeah, Nevermore. I need to replace soon. Like the part is cracked like since the beginning, and like it's falling more and more apart. So I think we might replace that soonish. Okay. Then let's quickly open the interface, and will tell us if the if the mister is wrong or not. Well, it looks good. Like there's no error state, and we see the heater bed has 25.6 degrees, so it's fine. If the thermistor and LD would be swapped, first the LD wouldn't work. The LD is working, and the thermistor would like show like random ass values, which most likely would be out of the range what Clipper accepts, and then like it would just go in and shut down. So that's sort of following. I mean the bed is somewhat level. So let's just do a home. Let's just do a home. Don't need to close that. Which is now homed, and then we can just say bed uh, screws tilt calcu screws tilt calculate. Headache asset. Which Nevermore version are you using? It's still the V5 Duo, I think. It's quite old. Um, the problem is why I'm like a bit hesitant to upgrade. The V6 is I think much nicer. But when you built the V5, you had to destroy the fans. So if I would upgrade to the V6, I would need to buy new fans. So not super into that. So most likely I would just reprint the V5 parts. Okay. Oh, yeah. It's not super level. So the front screw is the base. The back left needs to be turned 2.5 minutes. So I'm just gonna like turn it quite a bit, and then we just retry. It's really nice to have a probe. Just imagine like you would need to like manually level this now out with a piece of paper again, and like it's never like correct for like forever. Such a nice piece of technology. So we overshot both sides a bit. Let's retry that again. We just do it a couple of times, and then like I had to, yeah, exactly. I mean, since we redid the rails. I've actually changed my headphone. when we redid the rails on the side, like also had to re-level the bed. I think we did something else, like I had to change the bed. It was an absolute pain. Because it never was like leveling after, and now it's really easy. And I also see like it now really works reliably. Like the fan is off, of course, now. But even with the fan on, it's very reliable. I still have sometimes that falsely triggers. But literally what I need to do is like I need to like pull the Bowden tube a bit up, like that there's more filament on top, and then it works fine. So I think it's really just like the rail being bad. We're getting there. 4 minutes, 7 minutes. It's already like good enough. The only thing we could maybe now do in the stream still, as a one thing I want to do is I want to add a heatsink to the RP 2040. How big is the bed on yours? Here? It's 120 by 120. Um, the flexible rail cars don't have for sure. Yeah, I don't think it's a problem per se with the precision, as much as with the it's just a vibration that causes like what because it's loose like cause vibrations. Oh, the LDs, Steve. Yeah, the LDs. Let's look for the LDs. Already forgot. One last attempt here. Look big on stream. No, it's not big. It's like 120, which is barely enough for some of the Voron parts. Actually, I had in the slicer, I had it configured as 110 by 110, that it stays away like 5 millimeters from the corners of the bed. And for example, the Nevermore part, I mean, this one you can't print on the V0 at all. There's one problem, but I didn't replace it yet because I need to print it in ABS, and the V0 is the only like enclosed printer I have at the moment. And like, oh, actually, no, for sure. Like, it's too big, so you can't print this here. The V6 you can print on the V0, but it's like this much bed left. Okay, this is cool. Accept. Um, let's check the LEDs. So the problem is, since we did the CAN bus conversion, we wired the LEDs differently, and now it doesn't work anymore. I have suspicion it's just like the pin we used. It's meant for the thermistor, and I assume there's some resistor or something on there that prevents it. Prevents it from like working and like putting the signal to the LEDs, because the LEDs kind of work. Like sometimes I see a little bit of red on one side, but it's not very consistent. So I think it's just like a wiring hardware issue. So let's just quickly turn this off, shut down. It's like mini camera. Not anymore. So let's just flip the switch. Oh, actually, the power switch I also need to replace. Like when I turned on, like it doesn't like snap into position. Like it's very sticky, and I have to push. Not very nice. So I need to replace it, but I need to figure out what part this is. Yeah, not nice. Okay, let's do our most favorite thing. Steve, I tried my best. I tried my best to have new panels. Okay. So at the moment, the LEDs are connected here. Oh, looking at this, it might be even stupider. I'm not sure if this is properly connected. It's not a good crimp. That far is for sure. I drive back home, so we'll be back in a bit if you stream, that is. Well, let's see how long we need to fix these. Thanks for dropping in, and thanks for the bad part. Should have gone with the annex. Yeah, I know. Let me consider that. Like I kind of wanted magnetic panels, but I'm also like really not in the mood at the moment to design my own, to be honest, because I have other stuff I want to do, and I'm not really like want to have like another project on the side. Um, so let's see. Okay, so let's see what ports do we have available. So as I said, this is the bad thermistor, and my assumption is that this is no bueno for the LDs. Technically, any pin should work. So we have a couple of options here. The one I would try is to use there's one free pin here in this like port in this connector. The X and Y end stops. Oh, sorry, I should lead forward. The X and Y end stops here, they are taken because of the sensors homing. So they are taken. Down here we have a couple of free ports. That will also be an option, but then we need to extend the wire quite a bit. So that would be a bit painful. Let's see. So if we use this cable here, it's just too short. Of course. Yeah, no, there's no more cable. Just too short to reach there. I think so. We can of course extend the cable, but it's a bit annoying. I mean, these are the same. We could check what this DuPont connector here has available, because like here the cable would reach. Like if we recrimp it, we still have a bit of wiggle room. So let's check. SKR Pico pinout. This is this SWD connector here. I'm not sure if this is documented. I don't see any pins for that. There is definitions for these. This is like below here. You have to trust me, you see source here. But on this side, I don't see anything SWD. I'm not sure if this is like some special thing. We do have... Oh no, I just want to say like we have a fan port available, but this is taken. Taken. But here, aha! The fan 1 port we only use for power for the LDs actually. And this might just be long enough. So if we carefully remove the cable, pin here, the only problem would be we need to separate them because the black wire, the ground wire, still needs to go here because the ground wire here is taken. But this is plus is the red wire here for the LEDs. We take 24 volts here. The minus is actually just a GPIO pin. So we can connect the yellow wire there. I'm not sure if we can do that actually. Let's take it apart first. We have to detangle the wires either way. SWD stands for serial wire debug, according to Google. Ah, okay. Yeah, that's like a special port and not for us. Okay, perfect. I think we cannot really detangle them because they're like twisted. So we need to at least recrimp one of these two wires. There's no way around that, I think. This one we recrimp because this was a bad crimp. Okay, so this one we can put back. It's also not pretty crimp, but it will do its job. Let me see. So the thermistor bed has ground on the top side. So that's here. Okay, so that's one. And then we need to fix this. So it's a shame that this cable is just too short. Because like technically we could put it here in this one. Like the first one here is IO0. Let's do the following before we recrimp anything. Like this cable is still fine. It's just like one instead of two. So let's just put this in IO0 and see if we can configure this. Right? Just like as a trial. And if this works, we can try to recrimp this. It might just work if we recrimp this. Like it might just be long enough. But more likely than not. Oh, we already extended this cable. I totally forgot. So here there's like a heat shrink. Then we just we cut it here again and just re-extend it. That's fine. But let's try this. I'll just make sure that this random cable is not doing nasty things in here. Just use tiny bit of this. Quick sanity check. Like there should be nothing wrong with using IO0. Like 0 sounds like a bit special, but I don't think there should be anything special about that. You just quickly scan over the pinout here. If this is used anywhere else, because sometimes they put like pins out multiple times. There's IO0, IO1. I don't know where 2 is, but then we have 3, 4 here on the end stops. I think it should work. Let me quickly grab the cable. That's a magic smoke cam. Seems to work. Okay. Um, that was the spool holder. Let's see if we get any bad action. So at some point after Clipper booted, the LEDs on the badge should turn red. Only one side now because we only have one connected. Red, no red, no red. So this does not work. Oh, maybe we should configure the we should configure quickly the new I/O port. Just like a suggestion. Let's take a look at the config. So bad light, underglow. No, which one is it? Ah, here, RGB. Let's just put this to GPIO 0 and save and restart. Yep. Yep, yeah. Now we have RGB action here. There was a bit of RGB action here. It was the wrong color, but hey, we're getting somewhere. So if I go to we now have LD here. The color is completely wrong. Yeah, there's something wrong. If you look here, I mean 5% speed, we get either way, Ravenkeeper. It's a bit hard to see on camera, but this is purple here in front, and this is white. You see, it's like if I put it like quite low. Now you see it's blue, and this is not blue. So this is no bueno. But this must be a problem with the LEDs themselves. No, it's not the wrong color order because you see here it's different between the section 1 and the other section. If it would be the wrong color order, it would be like the entire thing. And it was working before we did the change with the canvas. Let's quickly check. Anyways, the thermistor port will not let you draw 24 negative through it. Well, we have power, right? And it's just connected to ground. The thermistor port, like if we check here, right? We connected it to the ground pin here. It's just ground. I don't think there's anything special, right? Like we now have it connected to the ground pin here, to the 24-volt pin on fan 1, and on the ID IO 0 here. So it's a bit of a mess, but I had more I was more hesitant to use the IO 17 of the fan. And I mean, we have signal, right? Like it's doing something. It's just like it's the wrong signal. So we have RGB order here. Chain count 100 is very optimistic, by the way. I think the chain count 3 should be sufficient. Because like this is one section. Like 3 sections basically. It might also be just that this one is toast. Like if one of the sections is toasted, the signal will not properly work. I fear that's what we're looking at here. Let's do the following. Let's recrimp the connector that we have the two sides, and we can see like what each side is doing. So if this side is doing something else, like this side is doing something else, then might be like a clue what's going on. I have a sample size of 2. Okay, so we need to remove this. We need to recrimp this. I hope my dual crimping skills are better today. Let's quickly grab the crimping box. Uh, 100 was fine. The strips have a lot of LDs in them. Yes, they have a lot of LDs, but for these strips, like not each LD is individually addressed. They are addressed in sections of like 20, I think, or something. You saw also like I had 2 sections now. One was red and the other one was green. Like 1/3 was red and 2/3 was green. And the red section, that is one LED as far as the Clipper software is concerned, because there's only one WS2812 chip for this entire section. It's a bit of a downside of these higher density strips. You can't address each LED individually. It's only like those groups, basically. I fear my dual crimping skill is not better today. I really only have one attempt here. If we have no success on attempt 1, I fear we need to extend the cable. How to get that sidebar in the config with all the quick link? I have no clue. It was the update of mainsail. Oh, you remember we did all the updates last stream? And then I had the sidebar. I think this is a very bad cable to crimp to 2 to 1. Sorry, I have to lean over that now, otherwise I don't see what I'm doing. It's okay. The top cable doesn't have the isolation crimped in, but it's doing its job for now. And it's just long enough here. Okay, let's turn it on. Um, CAN board upgrade day. Well, you can just re-upgrade mainsail, like that's completely independent from Clipper. Okay, so now our attention goes here. See, and this one is completely red, and this one is completely broken. What it means, so let me just quickly set like green as color. So this one is correct, you see? This is green. And this is blue. It should be green. And the interesting part, again, is it's a bit hard to see on camera. Let me quickly find like a different value where it like becomes more apparent. Oh yeah, oh. Yeah, it's even like if I change the brightness, like it changes the color completely. It's just screwed. Oh, that was perfect. Ah yeah, perfect. So, Steve, look at this. You see like this section here is red, and these sections are green. And this red section is one WS 2812B chip, like one of these like RGB chips. So this one chip controls the whole section. And what's happening here most likely is that this chip is not working correctly or it's broken. But also be a bad connection, so we should double check the solder connection here. But basically, if one of these chips doesn't get a good signal, like everything behind them in the strip is just broken. So this is not good. Try forward and 5 and see if they change. They don't. I guarantee you. Because before we had 100, it was the same, right? Like it's 3 segments. It's also like if you look at the strip. Something tells me we'll need that anyways in a second. If you look at the strip, you see like this is one section. It's not like the small LDs where you have like a lot of these like intersection points. It's like one section, two section. And then you see here, there's the chip. This is the RGB chip. So this one chip controls one segment basically. And all the LEDs basically in the section they all get the same signal. Yeah, AliExpress already delivered. Let me just double check. Yeah, this is 24 volts. Yeah. So we have to change the strip, I guess. Like there's no way around that. And it means we have to remove the panel. And technically, it could also be that we have a bad solder connection here. Because we extended the cable here, right? It would be quite unlikely, to be honest. Okay. I bought the PCBs with the LDs for Voron, so I can just snap some LDs. Yeah. I actually really like these two. I just didn't order them back then because I was like, oh, I still have LD strips. Let's just use the LD strips. So that was my reasoning back then. I actually just think we can keep all of this in place. We just have to loosen these. The only ones we need to remove are the bottom ones. Okay. And we learned we can just like really yank on them. Oh, we had to cut them. I remember. Totally forgot that. Let's just take a look. Oh, yeah, well, that would do it. That would do it. I guess there was like not a lot of cable left holding that. Yeah, let's do the following. So this yellow cable is already extended. So let's just replace the yellow cable. Well, luckily it was a data wire, not like anything voltage related. Yeah, you see here we extended already. So I think what happened is we just pulled on the cable. By we, I mean me. Um, not deflecting blame here. So it's just like, yeah, it's a quick fix. It could have been worse, and we don't have to. We have to do any crimping. So that's a nice failure mode. It makes a change, yeah. Only thing this that was we lost the spool holder. The only thing that's a bit challenging is we have to, as always, solder like a little bit in here because it's a bit constrained, but that's not a biggie. Not a biggie. Oh, I've got heat shrink. Let's preheat that. Heat shrink. Okay, so solder time. And yes, usually you should have like a extractor fan thingy, but it's a bit awkward because it's up here. So I just stop breathing when I'm soldering. I think for one connection is fine. Yep. While soldering iron is out, solder the two yellow wires to a third, so you only have one crimp. Yes, that would be a good thing, Steve. Um, but then I would need to recrimp. So for now, because it's crimped and it's working, I would just keep this as is for now. But if we redo this, we will solder like a triple joint, 100%. Okay, so then let's run this cable. Oh, it's quite a maze. So this goes here and then under the... I actually noticed something really weird. I mean, it's not weird. I know what's going on. But since we did the canvas conversion now, I sometimes have like a bad signal on the camera. Like the camera is the white cable here, right? And I noticed that when the white cable, because it is like quite close to the canvas cable here, if the canvas cable is in a certain position, I get a bad signal because of interference. It's a bit annoying. But yeah, it's downside of these like white connectors. Like they're very sensitive to interference. Let's see if I can um, maneuver that through here. Yeah. That's perfectly in the. Ah, here we go. That was quite some extra. So that's the old one. Maybe you need more twist on data pair. The data pair is not twisted at all. That's most likely the main problem. Because I use the parallel cable. And usually it's not that necessary in short runs. Like because like for the V0 it's like a very short distance. Um, so I kind of skipped that because you've seen which cable I used, right? Like it's just like 4 parallel wires basically. But that for sure causes the issue there. The problem is like at the end section where it interferes with the white cable, it will never be twisted because it's basically where it comes out, right? Where you route it. But yeah, what would be one solution would be to just use a different cable there. That's not old ender wire, but like yeah, it's same concept. I bought these cables for motors, to make cables for motors. Um, and then I misused them for canvas wires. They work great because they're like super flexible. And if you combine them with like a more rigid cable, it's really good. But yeah, it's the missing twists are something. And if I do a bigger printer with canvas, I 100% will not use these cables because they will not go well over longer distance. Okay, all or nothing, right? I don't think we have any smoke danger. Power is on. Let's see if we damaged the chip with the broken cable, but I'm pretty sure that we did not. Use the same wire. You twist them at least 2 twists per inch. They're sockets that don't matter. Yeah, I just have to pull them apart. We can do that, of course. But for now, like it's in place. It's working. I don't have any canvas communication issues. It did the same. I think we also have to replace the strip. Yeah, see? Still doing the same. No good. No good. So I think we need to replace this strip. Yeah. You see, like here now, for example, like now this is pink. I know it's really hard to see on camera, but this is pink and this is green. So it's like still doing the 1 section, 2 section. So I would just replace that strip and then call it a day. I mean, we now have it out already. The only thing we need to do is like we need to do the cuts again. Let me get scissors. I'm back in a second. So it's also like something I learned, like you need to be really precise with the cut, like because of the many LEDs, it's very easy to cut like into a LED. So then, how do we cut them? So on the 24-volt side, we removed some material. It's a bit barbaric, but we need to lose 4 millimeters somewhere. Yeah, that's how we did it. Oh, the glue is ganking up my scissors. Let's just use snips for a second. Or you can also just cut from the... So the strips Neoboard is definitely easier. But they don't look as nice. Yeah, it's quite quite narrow now here, but should still be fine. Okay, well, let's solder this way. Okay, that's the old one out. And the new one in. No, I didn't do that. I cut it the wrong way. I left the pad on the end, but the data direction is here. Ah, shit. Ugh. Let me see if I can scrape the copper free. Could you do this here? 1 second. So I'm just scraping off the material here. Well, I actually can like. That's not super easy to turn. Like I can turn the camera down, but I have to loosen the ball to turn it back up. Okay, it should be enough to solve it. And we can also finish the job on the other side. Okay, let's do the 24-volt wire first then. Let's see. So let's first put some copper on it, some tin on it. I'm using like the biggest soldering tip imaginable. I remember like when I was still a student, we had a project where we had to solder these LEDs. And it took me forever to solder these LEDs. It was impossible. To be fair, like the pads were a lot smaller because it was like the higher density ones, like the single higher density. But man, I was like, yeah, like the 24 connection here is quite solid, so that should be fine. Let's just leave it here for now and fire. We have you see a bit of LD here from the tool head. So they should turn on red. The whole strip should turn red. Shrink wrap, yes, in a second, Steve. First, let's see if it works before we seal it up. It's doing the exact same thing. So it's not the LEDs, then it's the connector. That's weird. But it does exactly the same thing as the other strip. Yeah, no, this one has solder on it, so I did not accidentally put the same one back. Okay, Steve, then it's what you said with soldering on the inside. So let's quickly put this back. Let's keep it here. We will need that. Lighter. What a shame. It would be nice if it just like the strip would have been damaged and we now changed the strip and everything worked. Yeah, but like it didn't work. Like we created this double connection last time, right? Or not last time, but when we did the canvas connection. And since then it doesn't work. So I'm fairly certain it must be the canvas connection. This double connection because like yeah, since we put it in, it didn't work. Yeah, these I also have to replace. Let's not break the cable again. Okay, so then let's look here. Yeah, then let's redo this cable here. I mean, at least one side is working now, so that's I guess 50% success. I'm just using the cable we used before. That broke. I always enjoy soldering like three-way connections. It's always fun. Especially with very short cables. That's the most fun. I think I need a bit more cable here. And then let's twist these two together. So these are one. And twisting them together is easier said than done. And let's actually add some tin on that before we do anything else. Let's also add something here. Um, sorry, it's sprint review. Well, no excuses. Trying to catch up. What happened with the magnetic panels? We gave up on that. The design that I printed doesn't work. It just they're not strong enough. So for now we just put on the original panels again. And then I will do some more research. Maybe I find some other magnetic panels. And then the other option is I design something myself or I use non-magnetic panels. These are the options on the table. But like for today, the panel project failed, unfortunately. Now we're trying to fix the LDs. That didn't work since I did the canvas conversion. I removed that top board here from LDO. And that had two RGB headers, not sure if you remember, for the two sides of the bad lights. And then basically what we did is we crimped both cables together. We put it to the thermist support here because I'm kind of running low on available ports. That didn't work at all, so the LEDs didn't work at all. Now we put them here to this laser connector. There's like IO0 and IO1. That worked, but only one side. The other side still had issues. Then we replaced the LED strip on the side, still issues. So now we figured it must be the connector here. So let's see if with the new connector, like we still have to crimp it, right? But like now we at least have easier time crimping it because only one wire, not two. Thanks, Steve, for this amazing suggestion. I think we can leave this relatively short, but I still want to have like a couple of attempts. Getting a bit messy here. I've been thinking about doing zero panels on my Visor. Yeah, that was also on the table, the zero panels. That was also on the table, but I was like, oh, I really want magnets. Magnets are cool. I like magnets. And I went with the project without any makes on printables. It looked fine. It's just like it's not strong enough. Like there are not enough like the magnets are just not strong enough. There are not enough magnets in that setup. There's 4 magnets per panel of like the small magnets, and the magnet placement is not ideal. And that's kind of where it breaks. So technically, I can use that project because I think there's step files, and I can just add 3 magnets per corner, and add some support to like take the vertical load basically off of it, and I'm pretty sure it would work. But I might also still go for 0 panels. It's just like they're clips. I don't like clips. I like magnets. Then maybe on the LDO board, one RGB is linked to the other and the count doesn't both strips. No, like so basically how we wired, like on the LDO, it was 2 different strips. It was 2 IO pins, so you could like individually control them. For here, this should just, that's how it did in the past. It just gives the same signal to both LEDs. They don't know anything. It's just like the first chip takes the signal. In this case, it's not parallel, so both chips should take it. Let's see what it does. And then, yeah, so basically how this works is like each of these WS2812 chips, they have a, like it's like some sort of a serial bus. So the first chip basically takes off the color it needs and then sends the other colors, like next LDs, basically to next chip. That one takes one off, sends to next. Takes one off, sends to next. So it's like this serial connection basically between all the LD chips. There's no data back. So just like is now both did the weird thing with one red, one red. At least it's the same now. Before it was like different per, now it's the same. I'm not sure if this is improvement, but yeah, like now both do the same weird stuff. So we now broke both. So you see here it's like yellow on the front and like pink on the back. Pink back, yellow front. This is weird. I didn't have this issue before. Um, I mean, I'm not sure if we can change the color, but even the color order shouldn't do that. With the color order wrong, it should still do the whole strip in the same color, just like a wrong color. And like the config was working before, right? Like all we did is we removed one of the configs, like we had RGB1, RGB2. Now we only have one RGB config there. Where is it? NeoPixel RGB. NeoPixel underglow RGB. So it's GPIO 0, chain color 3, which is correct. Color order, I mean, you can just try GBR for fun, but like this would be really weird if this would be incorrect now. I mean, now it's different wrong. Now it's different wrong. Oh, now this one is red again and has nothing. And this one is blue and other blue. You may backfeed and they're sending wrong data to the secondary. I dumped springs for rubber stops. The springs let the bed move too much. Yeah, I also had a discussion like earlier today. Like I have two rubber stops, but only have one. Like I need three, but I only have two for some reason. Like I lost one seemingly. Um, this is weird. Like, why would this be such an issue? Like, I'm fairly certain I can run the two in parallel. I'm fairly certain. Like, I don't know. Like, what would stop me from putting them in parallel? You may have feet. You're running in parallel. Yeah, I'm fairly certain I did that in the past. So I'm not sure if there's like a bad connection anywhere now. But because both are now bad, like in yeah, it's a normal crimp, and like I'm fairly certain I can solder like three wires together. Hey, let's quickly undo the config change because I will forget about that, and then RGB, safe restart. If you just run one, does it work correctly? Like, one side did work correctly before. And then we redid the connector now, and now both don't do anything anymore. But it's also funny because in the beginning, both did the same wrong thing, but now you see this one is red, this one is green, so it's all messed up. I don't think you can. One strip is sending signal down the data signal wire. That's the yeah, like the strips sent down here, right? The first chip takes the signal on both sides and then sends it on. There's no communication this way. There's only communication this way. So you can put them in parallel. I did not want to solder or crimp them together. Yeah, but like, I mean, I can re-solder that now. Like, I don't see the problem with soldering that. Steve, what do you mean by backfeed? I will look up my config. There shouldn't be something. I don't think that is something you need to configure. Yeah, we can redo this solder here. Let's try this one more time. We can also do the Wago connection for a second, right? Just to make sure that it's not me. I mean, it would still be the crimp, would possibly be wrong. But we can just quickly hook this up with Wagos, just to see if it's me being incapable. I have to destroy this one. Yeah, let me see, how can we do this without crimping again for now. I put money on you have to run wires from the end of one side to the other. Yes, you have to do it, Steve, if you want to control them individually. Then you have to do that. But now we just accept that both are the same. Here's what we can do now, right? Like, if we do it like this, we can easily test out what happens if we only have one strip, right? So let's do both at the same time, right? I just hope I can plug this in now. Bit ridiculous setup. Okay, here we go, right? Like, both are connected with the Wagos. I don't remember if the two on the left, you look at it now, are the same or different. The two on the left, same pin, and the three connectors in the middle of the three cables. I can't quite follow you. Okay, let's see. So this is both connected with Wagos. If that doesn't work, Steve, let's try one connected. And then if your theory is correct, we should see correct behavior with one. So we have no LD yet. You will see it on the bottom, like when it gets on the bottom red. Incorrect behavior on 2. Okay. So now you see like it should be off, like it has the red on the back. This is what we saw like very consistently now, actually. Like very consistently. So let me shut down. It shouldn't matter now because it's just like a GPI open. And we can try another GPI open, but I don't think there's anything special going on there. Okay, so I remove this side. Let me get a tiny bit of tape. Now only this side is connected. So if the theory is correct, we cannot drive them in parallel, and this is the issue. We should now see perfectly correct behavior. If we still see wrong behavior, I'm fairly certain it's the crimp or the pin. Now it will work fine. Okay, Steve. Let's see. Now it's blue. It's different. Now it's red and blue, so it also does work. It's different wrong. So now it also doesn't work. So again, like if the RGB GBR would be different, like it should not be because we used the strips before with the RGB configuration. It should still be like the entire strip should be, unless it does with RGBW, but that's not configured. Mm, because yeah, we used the strips before. Did you measure the voltage? Or if it would be not 24 volt, it shouldn't turn on at all, right? Let me. So Neo said you used a different pin. We have ground and 2 times 5 volts. So the only other is the IO1 we could use. No LD effects plugin. No, it's very basic. We don't do anything special right now. And it just doesn't do it. But it's funny that it's different. I would have expected any different behavior. Let's try it this side. Just for trying. Because here we also have a solder connection. Maybe I'm really bad at soldering and this doesn't work. So let's disconnect this one. And connect this one. Yep. Okay, let's see. But if we don't get to work, I would also just leave it for now. And it's like an extremely unsuccessful stream. I'm unsuccessfully trying to pronounce unsuccessful. And now let's look for a different solution. Maybe it's just like that these IO pins have something fancy going on. No clue. It's still wrong. It did red in the beginning, but now it should be off. It's not off. It does the thing again where it's like half red. Yeah, this should be green. Now it's doing again like a half. Let's do something repeatable. So off seemingly works, great. And all the way blue works. The funny thing is, if I now like do this repeatedly, so now it should be red. It's pink. It's the wrong color, but it's consistent. And if I now do it all the way down to off, like it's red here and here. If I now put it all the way up again, it's the same pink. And if I put it all the way down again, now it's different. Okay, shit. Now I thought like I had some pattern. Yeah, now it's doing this again. But it's somewhat repeatable. So if I do the same things over and over again, I get always the same result. Um, so now it's green, which actually is correct. Cool. And it's off. And it's green, and it's off. So this is repeatable. So I don't think it's a bad signal. If it would be a bad signal, I would expect like random results in a certain sense. And also the off is very, because off doesn't mean like that you don't send voltage, right? You send a signal with the color 0 basically. And sometimes this one happens. This is weird. So I don't think we have a bad connection issue here. Black is off, yeah. It still has 24 volts with off. It's just like, and like the color is somewhat, I mean like with a, you can say it's in the ballpark or what it should be. Like blue is somewhat blue, green is somewhat green, red is red. Now this is like screwed up again. I think it has something to do with the brightness. Oh, but now I put the full brightness and it's still like the first section is still bad. No, I don't use the 5-volt pin. I don't use the 5-volt pin, Neo. Uh, I use, I mean, it's a bit hard to see, like the 5-volt and ground, they power the Pi. Because this port is strong enough to power the Pi. And then we only use the first pin here with GPIO 0. We could try now to just swap it over to GPIO 1 and see if this makes any difference. But this is weird. A bit erratic behavior. Um, I mean, the white works. Nice. And now it's getting green, like in the middle. Something is weird. Now it's the count. I don't think it's a count. Like we can put the count back to 100. It's bad light, on the go. But I guarantee you this makes no difference. I also think the chain count might be wrong. But Neo, what chain count would you suggest? Like it's, let's see. We had chain count 100 before. Um, yeah, the thing is like your 18 LEDs have 18 controllers. My 90 LEDs have 3 controllers. That's the difference. But yeah, like, let's see what it does. So this is now green. Now it puts it to blue when I put it to green. Blue is blue, yay. Yeah, I guess something. It's so wrong. No, you see it. I mean, you don't see it, but like it does the blue pink again. So it's so great. Like the chain count is not a problem. If I do the chain count, that just for fun, if I put the chain count to 1, right? I just put the chain count to 1. Shouldn't use 6 if you. Why would I use 6 if I have 3 controllers? Oh, you see already now, like the first one. Like you only can look at the first one now. Only this one. This one you need to ignore completely. It's only the one on the back. Um, it's red. It's turquoise. It's not. It's the wrong color already. It's blue. It's pink. I guess. You could argue this works. The first one works. But you also now see what I mean, right? Like we set the chain count to 1, and the whole section is the whole third basically is controlled. It's because there's one LD controller. But this seems now solid. This seems solid. That does how many sections are there? 3 sections, 3 controllers. You see, this is 1 section, 2 section, 3 section, and this chip here in the center, here, here, and here is the controller. But this works not perfectly. Like this section here works brilliantly. Let's do the following. Let's do the hardware change. Oops. Yeah, screwed up. Let's quickly put the second strip back. Now we should have 1 on each side and see what that does. I might have snipped it off wrongly. But it's like the one side of that strip is all 24-volt rail. We checked that like the when we did it initially. I mean, we can also use different LDs. I also have like LDs of the other ones, right? Like with the single LDs. So hey, my chair keeps eating the cable. Let's see. So yes, it's random again. So now it's like red here. Like it was red in the beginning, in the center, like on the end. Right? Like again, we have only have to look on the last third on each side. It does the same on both sides, which is great. No, it's random. No, it's weird. Um, Not quite sure. Um, let's do one more thing. We do have RGB stuff here, right? This cable here is the LDs on the bottom, which add at least 10% speed. Let's do the following. Let's just swap the two and see what happens. So here we quickly need to crimp one cable. Power off first. We need to quickly check the pinout. So there's it's the servo. So it's yeah. So the blue cable, of course, is the signal one. So let's do the following. Let's get rid of this short one here. We carefully let it just stand as a little antenna here. Nothing can go wrong. Do I have some like random ass? No, I don't. Okay, let's just take a bit of wire. So let's quickly crimp this at JST. And then just plug this in here and see what happens. Like if the I have the suspicion it's maybe the I/O pin that we use there, that this is like not really like suitable for RGB LEDs or something. I don't know. As a side note, would also be nice if we would have chosen like a standard color for these RGB things. Like now it's blue and yellow, like the cable color, I mean. So we put this here. And now this connects to the bed. Let's see what happens. So when it boots up now, everything should turn red. I show you this side. Nope. My display wants to go to power saving mode. So it should get all red. Okay, it's not the I/O pin. Again, it does the same random shit. So something is wrong. Don't ask me what. Let's try one LD strip only on one side. Steve still has the idea or the suspicion. That's what I'm looking for. Suspicion. It's because we put both parallel. Strips more RGB, more performance. Everyone knows. Yeah, exactly. It's like it's essential. Like if you want your printer to do speed benches, you need RGB in every corner. It's essential. Are the LD strips on the bottom the same as in chamber? No, it's different one. It's the older style. I mean, the next step now would be to replace these with the standard ones. But this does not give me any hope already. Yeah, this is the one we have plugged in. So we only have one connected. And this one also we did not touch. This was working. This was working. And it's doing the same random shit again. Like, I don't know. Like this, I had this working, right? I had left and right. We swapped the strips. At some point, remember we had like I had like random LDs like just burning out in the strips. And then we replaced them with this one. And it was still connected to the LDO board and it was working. And now, like 2 weeks ago, right, like we removed the LDO board And instead of the LDO board, I connected them directly to the main board. Then they didn't work at all. Um, they did not work at all because I think just like the thermistor IO pin that we used is just not capable of that. Like there might be some resistor or something on there that prevents it. Or it's like differently connected to the board. Then we now connected it to the IO0. We still had random behavior. We connect one random behavior, we connect the other random behavior. We now connected it with the known good IO pin that drives the bad LDs. We still get random behavior. What do you use for the config? It's RGB. They don't have white. I'm fairly certain. No, they only have 3 resistors. RGB. Again, like this was working, right? The only thing we changed on the config was the IO pin. So the RGB GBR, it can't be wrong. I mean, we can try, but unless that LD strip like magically grew like another LD and now has like GBR or GBRW or something like. I mean, we tried GBR as well, right? We already did that this stream. And they don't have white. Like I guarantee you, they don't have white. I don't know what's wrong here. Because again, like if I now plug this back in, it should be fine. I mean, the other option would be still the ground connection, that does something fancy. I wouldn't see how, why. The fan is also 24 volt. Like we can, I don't have a good point to measure the voltage, but it's 24 volt. Like I don't see how this would not be right. Like this pin is connected to the input power, and we can check the pin out. Yeah, this is the 1224 volt here on the side, and this one thermistor is ground. Hmm. No, I'm out of ideas. I am out of ideas. I don't know what it could be. Let's do the following. Let's put them in here that are secure. Let's disconnect the 24 volt and just have them off for now. Readings via resistance, so maybe the ground pin there I'm as lost as you know, yeah. Am I motivated to check the ground connection? Let's check the ground connection, but it's the last thing I'll do. This is a bad crimp, just for the record, but like it's still like it connects fine. Okay, so let's check the ground connection. So let's extend this cable with the ground. I'm just using now like random cables a bit, just like because I'm very short on black and red. So we know for now for testing that white is ground. But Steve, I think it's the first time I saw you not having the solution. I'm almost disappointed. Um, but I think Ballistic Tech, you had like the one question: are they the same as in the bottom? And now we connected them. We now connected the LEDs on the side to this port, but this configuration was different, I think. Um, this is a safe configuration to start. Let's quickly connect the ground. Let's connect the ground. And then, but also let's double check that because I think the LEDs on the bottom might be GBR or something, like not RGB. Not that we are like tricking ourselves now. Like the LEDs you used, like link, or I don't like them right now. That I can tell you for sure. But yeah, you know, like it was working. It's not like we put them in. GRB, GBR. One of the two. The non-RGB order. Don't quote me on that. But yeah, again, like the config was working. So let me see. Yeah, I think the quickest would be, let's quickly solder this white wire to like one of these JST connector thingies. Okay, this has ground and the connector from here. So the only thing it doesn't have is a 24 volt because like these on the bottom are 5 volt and these are 24 volt. Link. Yeah, I can check, but I need to look it up. Like ordered them a while ago. So do you not trust my preliminary electronics? It's perfect. Yeah, like that would be the worst case actually if we destroy the main board while messing around with it. So yeah, this is the last attempt. Let's check the different like configurations again, but and I also don't want to turn the printer now because there's so many like random SKOs here. Let's see. Okay, this should be fine. Yeah, this is fine. Let's see. I didn't see now anything. Mm, so let's quickly check the printer config. I never find these. NeoPixel RGB. Wait, but now we need to look for the NeoPixel underglow. And these are indeed GRB. GRB. So let's change this to RGB. Now they're blue. Wait, what did we now set as a config? NeoPixel underglow RGB. We set now RGB, and they lit up blue. Um, yeah, same shit again. Like this is blue, this is white, so it's still like it's wrong. I cannot tell you what the problem here is. Now it's white, blue, pink, white. I really don't know what the problem is. But both sides do the same. That's the positive. I'm yeah, and it's very consistent that off is red, off, off. So there's some system to this madness. So you say it's a strip, and I would fully agree, Neo. I would fully agree. If we wouldn't have swapped the strip already, we did that. And I have two strips doing the exact same thing, right? Like both are, you see, red, off, off, red, off, off. It's exactly the same on both sides. If a controller would be broken, I would expect one side to be off and not both. I don't understand it. Like I'm just out of ideas at this point. Um, and it worked. That's like if we would have put this in now and it didn't work, sure, there's something wrong, whatever. But it worked. Like all we did is we connected to a different MCU. So it can't be the voltage. It can't be the signal or the configuration. I'm not sure if I will ever find out. Wait, tell me. What do you mean by pin names changed? It's connected to the right pin, right? Because if I change something, there's the effect. If it would be the wrong pin, there would be no effect. Well, yes, like we changed the pin. Like it was like UMB colon something, and now it's just the MCU pin. Okay, so I will leave it for now. I just need I need to think about that a bit. So I will just leave the Vago here. This is safe. This is fine. Like nothing can happen here. Um, I will disconnect the 24 volts so that they're off. Steve, I would fully agree. Cheap chips from China, but if it would be broken again, like I would expect one to be broken, but both are doing the same. So something it must be off, like config wise. Let me just like have this not directly on the main board, maybe. So I'll just keep these connectors here for now, and then they're just off. I can live with that for now. But I am not gonna lie, this is a bit frustrating, and it's late, and I'm not in a mood to like sink like another 2 hours into LD strips. This is really weird. Like I've never had such issues with these LD strips because they are exactly the same as the other ones. Like with the individual LDs, it's the exact same chip. It's just like the LD setup is a bit different. Oh wait, not. Okay. I dropped the spool holder. I need to go find that. Oh, let's do the side panel here. You know what would be nice? Magnetic panels. And you can just, snap it on. Man, all my no drop nut, no nut drop nut. I will never get this straight. Um, they all break. They all break. Well, that's it. It's back together. Let's quickly. We need to change the configuration for the bottom again. I will keep this fancy debug cable, and maybe we are successful. Another day with LDs. This is weird. Like I've never had something like this. Well, so out of like 3 projects, one worked, which is like quite a good quote, I would say. Yeah, see now it's like it's completely green because we changed the config. It should be completely red. So let's go to GBR, I think. No, I will never get this straight. GRB, yeah. But it's funny, like now it lit up blue, right? So this is also like a valid configuration. So it's just like RB swapped. So it's really dynamic. It's good. It's good programming. I like that. Now it's green, red, perfect. Here we go. That works again. Well, 3 projects. We do not have panels. We do have, thanks to Neo, a very beautiful helper here for the bed. We still don't have LDs. The only benefit is now they're not lighting up randomly anymore. They're just off. So I count it as a win. I have no clue what's happening there. I think my next approach would be to swap the strips. I do have the normal ones with the individualities. Um, it's 120 byte. It also connects left and right with your thing. Like there's not like there's a millimeter of wiggle room. I don't know how yours is. Oh, it's indeed. It's 11.9. They cheated me for a millimeter. There should be no wiggle room. Like for me, there is pretty much exactly 1 millimeter. But it's still like it's pretty good because I can just put it to the back, and that's it. I do have a second cheat, right? But also here I have a bit of oh, you see this one here? Ah, yeah, yeah, yeah. You remember discussion with the nuts? So the lock nuts, they're a tiny bit taller. So now the spring doesn't compress the thing what you mentioned. Like the part is not connected. The spring doesn't connect onto the part, so it can wiggle a bit. Yeah, yeah, the spring. So yeah, it's fine. It's still like it does exactly what I needed to do. Like the back thing is all I need, to be honest. Okay, well, that was extremely unsuccessful stream, even for my standards. Um, yeah, I'm a bit disappointed, to be honest. Let's see. So, what is the plan? The plan is that this machine is very busy at the moment. So I'm also like very hesitant to do anything that has to do with printing mechanics itself. So there's one thing I still want to do. I want to change the X rail once that arrives, and I want to do the nozzle brush. Um, that's something I want to do most likely next week. I'm not quite sure if I'm mentally ready next week to take another crack on the LDs. Um, so let's see. But yeah, so the nozzle brush and the rail is on the list, and then I think for this machine it's good. Potentially we will replace it Nevermore, but that might be a little bit like further down the road. Um, and that's yeah next week. And then I do want to take a look at the Poor Man's Corks Y. It's actually printing very nicely, like very nicely. Like not super perfect, but it's like really getting there. So let's take a look at that. Just take a peek, just take a print and show in a certain way. Just I have a couple of parts to swap out most likely then, but nothing too crazy. That's also on the list, and then I have a big project coming up. Um, but then that's for like in like 3-4 weeks. Cool. Yeah, I would roll it up now. Um, and thank you everyone for tuning in. Thanks for the help in trying to make my LDS work, which was not successful, but still, thank you everyone. Yeah, and it's printing nicely. Let's tear it apart, and yeah, exactly. That's how things go. But this one, it has some work to do, so it can't be teared apart at the moment. Well, that's it. Enjoy your weekend. See you next week. Bye.